Hello, everybody. Excellent. So I'll be talking, my talk is titled Nouns Are Better Than N-grams. What I was thinking is nouns are better than tokens. And that's what I'm going to be trying to show, and we'll see where this goes. So I have a lot of database data architecture background, but a few years ago I thought it was a good idea to go get a master's degree, which included some text analytics, and it seems like everything I do the last 4+ years includes preparing text for analysis, which is, I guess, why I'm talking about this. So the observation here is that the aha for us in the project I've been part of a couple of years ago now is that we didn't like the tokens we were getting from the standard tokenization pipeline. So we tried using part of speech to identify the things that we did want. So I'm going to do an overview of that, make it as brief as possible, get into some Python notebooks to do a compare and contrast between the two. I expect we'll have time. I've got some pseudocode of what this Python notebook implementation looks like deployed to a Spark cluster, which I've done and which runs. And I expect lots of time for Q&A. Ordinarily, I like to be more interactive, but I think it's a bit too echoey. Go. So, if you're thinking maybe there's another session, not quite sure, this may be all you need to know. So a part of speech-based token extraction pipeline. The idea is we can use part of speech, go through, tag your text with the part of speech, and then pick out the tokens for the parts of speech that you care about. In our case, what we care about are nouns. That's meaningful for our analysis. So what I'll be showing is noun extraction. But you'll see that the function implement, you could just as easily update it to grab verbs, to grab adjectives. The tokens you get are human readable. They didn't go through a stemmer, so when it finds customer service, you get customer service. Very human readable, very friendly when you're talking with your business users later, showing these tokens. Assuming you're looking for phrases, noun phrases as well, that's one of the tags that gets added, at least for the tools that I've used, which means you get phrases naturally. So at customer service, as an example, this is one of my frustrations with the standard tokenization pipeline. You'll find customer, and you'll find service, and if you stem them, then you might get cust and serve. But customer service as its own separate thing won't show up. With a part of speech tagger, that will. So you get phrases naturally, you don't need to go into n-gram generation for that. And the stop words, the standard English dictionary of stop words, all go away for free because they take on a part of speech that you just don't care about, right? They're conjunctions, they're determinants. And if you didn't pay very good attention to grammar, your 8th grade English teacher, like I did, you'll get to learn about grammar anyway. Then you can use singularize, the Spark NLP presentation that I went to a couple of earlier today. I think they call this normalize. So taking plurals and collapse them to the singular form so that you don't get minor variations of the word showing up as different tokens. This is what I'm going to be talking about. So the standard pipeline, very briefly, tokenize the text, convert tokens to lowercase so that words that just happen to start a sentence should look different from words that are in the middle of a sentence. You apply a stemmer. Stemming is kind of interesting. Part of my own mental process that got it started. Years ago, I remember stemming experience, and it turned into experi. E-X-P-E-R-I. And it didn't look right to me, right? That didn't feel like human readable. What is that? Why did it? And if you think about that, I think experiment will stem down to experi also. So are experiment and experience the same thing? It doesn't mean you can't do analysis with it. Obviously, if you've been to other NLP presentations, people are doing a lot of amazing stuff. Anyway, so a stemmer removes stop words. You might generate n-grams, you might do, was it a spell checker I saw on the Spark NLP presentation? A whole lot of stuff. This is our standard approach to, and this is what you see if you're out looking, if you're browsing on Stack Exchange or just looking for examples of doing this. This is sort of the pipeline people talk about. So I think I've covered these challenges. to me, the tokens are just, they're not as readable. They can be difficult to explain to business users, and if I'm explaining tokens and why Xperi is meaningful to the model and what is it, where did it come from, I feel like I'm already in a losing conversation. And if I'm not having that conversation, then I'm sort of arguing for a black box. And anytime I've tried to argue with users that they should just trust the black box and it's okay, that's a losing conversation as well. I think of this as we're applying a bunch of sort of human expert, or in my case, non-expert, because I'm not a linguist, I'm not a grammarian. I did pass English, but I had other topics I thought were more fun. We're applying rules for how we think language works, and part of the deal with language is there's exceptions to every rule. So then you get more exceptions, more rules you need to write, and it just kind of goes and goes. So as I've already said, the solution that we've been trying, and I've been surprised at how easy it was to develop and how performant it can be, is to replace that standard pipeline with tag the document with its parts of speech, and then extract the tokens that match the parts of speech you're interested in. So, and I mentioned these benefits. You can use, by getting the phrases, you can use this in lieu of n-gram generation. You get the English stop words for free. And the nice thing is, you get any word that fits those parts of speech you don't care about, whether they're in the English stop word dictionary that you pick up or not. They just don't come through. Okay. So my intention is to spend almost all of our time looking at what this looks like. So I've got I switched away to the notebook, even if the display did not. Okay. What is it doing? Thank you. So we've got ourselves a very simple sentence, just so we can see this. First, I want to show you the standard token, a variation at least, on a standard tokenization pipeline. And where'd my mouse go? There it is. So we tokenize the sentence, and our sentence just turns into a Python list of the individual words. Lowercase it, all good so far. Remove the English stop words. So now we're down to quick brown foxes. What is it? The and over go away. Run the stemmer on it, and most of these are pretty good. Quick brown fox, right? I intentionally made it foxes before, now it's fox, good. Lazy with a Y becomes lazy with an I. But overall, not too bad. And then I just end with counting the, so what all did I find? This is fast, pretty easy to implement, pretty easy to understand. So as a point of comparison, very similar setup, but now using a part of speech tagger. So pick up my text. So I've defined this as a function. I'm going to come back and we'll walk through the function. I just want to show you the output first. And this is a notebook I originally developed as sort of a development environment. As I was building this part of speech logic, I would go pick up an individual document, an individual chunk of text, and I would pass it through this because I wanted to see sort of what is the part of speech tagger seeing, what is it telling me about this. So when I run this, the whole text I'm seeing, in this case it's one sentence, so the whole text and then the first sentence are the same thing. And then, the way this part of speech tagger works, we'll first iterate through the words of the sentence, and then we iterate through chunks of the sentence. So, first word, the. Its part of speech is a determinant. I don't care about determinant, move along. Next word, quick. It's an adjective. Don't care about adjectives, moving along. A noun, plural, NNS is for plural. So I'm going to keep this. And I also already ran it through the singularize function, so I found my first thing I'm going to find is fox. Keep that. Next thing so we skipped over, jumped over the lazy, oh wait, dog. Let's keep the dog, keep dog. And now we're done walking through the words. Next up we find a noun phrase, the quick brown foxes. Well, I don't want the quick brown foxes, the is a determinant, so let's strip that off and just keep quick brown fox. Verb phrase, prepositional phrase, don't care about those, a noun phrase. So we'll pick up lazy dog. So in this very simple sentence, the end result is we find 4 features, fox, dog, quick brown fox, and lazy dog. Running time on this, let's run a bigger blob of text because I expect the part of speech tagging to be slower. I've been pleased at how fast it can be. Let's see here. I went out to Wikipedia and grabbed the opening paragraphs for data mining. That seemed apropos. So we tokenize it and lower it and stem it and remove stop words. Get a count of all the things. So down here, I turn that whole process into a function so we can time it. We get a whole bunch of stuff. 328 milliseconds for, that was, 4 or 5 paragraphs of text from Wikipedia. It's not a huge document by any stretch. This generates a whole lot more output. Since my part of speech is designed to, I'm intentionally generating a lot of output because I'm using this also as a debug. Ends up being about the same running speed. I'll scroll back up a bit. So we've got a summary. One of the side effects of the singularization function, did you know that the singular for data is datum? I had a professor in school who was militant on that topic. Good way to get marked down on a paper. But we also pick up out of this, come back mouse, okay. We pick up data mining as a phrase. Here in the data mining, in this subject, we'd expect that with multiple occurrences. That won't exist in that form, of course, from the other process. So I promised. So the function that does the work. The particular library I'm using is something called pattern. It's readily available. The one thing about pattern is, unfortunately, today it is Python 2.7. That's what they prefer. That's what they require. The Python 3 compatibility is developed. It's on the development tree, on the development branch, and that's what I've got installed. I've got some information in the references for how you would install that. This is not the only library you can do part of speech tagging with. This is just what I'm using here. So Parse Tree, it does the work. it goes and builds this tree of information for each of the sentences that makes up, so it breaks up your document into sentences, and then within the sentence it tags each of the words with their part of speech as well as identifying the chunks that make it up. So what do? We walk the sentences in the tree, and then for each word in each sentence, see if it's one of the noun types. If it is, keep it, and if it isn't, then just loop and keep going through till you're done. Once you've walked through the words in the sentence, now walk through the chunks in the sentence. So if the chunk type is a noun phrase and the first word is of type determinant and the chunk is long enough, you do some of these and you'll start seeing chunks like the dog. Well, the dog, once I take off the determinant, is down to dog, and I already picked up dog as a word. I don't need to pick it up as a phrase, so I skip it. Sorry, I jumped ahead to the next one. This is the test to see if the first word is determinant. I've since discovered, about literally like a week or two ago, situations where a noun phrase starts with two determinants, and so I stripped off one, and I was left with a noun phrase that started with a determinant, and people I work with were like, bad feature. Not rocket science. And then here at the end, I've just got this set up to print out what it finds. So one of the things that I've been very excited to see the Spark NLP library. I hadn't heard about it until I came here. One of the observations that they made is part of speech tagging is something where you should expect to need to, a part of speech tagger is a deployed machine learning model, right? They've gone and learned a model of what parts of speech different words exist in and how they relate to each other and so forth. For your domain, there's a very good chance you will need to train your own part of speech tagger as well. So far, that's not something that I've needed to do, but I also sort of expect that that's in my future as well. So there's some additional complexities if you go down this road, for sure. But you also get better looking features at the end. That's the, oh, there was some, so let's see here. When I went into this, I went into it with this idea that part of speech tagging would be difficult to implement. It was going to be this very difficult code to write. It was going to be hard to maintain. It's going to be really hard. I learned that it wasn't. It's one of the surprises for me. With the pattern library, this is not the first library I tried. I've discovered that it can be very highly performant. Well, we're seeing here that in my one sample test, it's approximately equal in performance, speed, and running time. So the last thing I have to show you now we're going to go figure out how to get this over there. So at some point, the corpus I work on is millions of documents, tens of millions of features once we get done with this. We wanted to run it faster, so although this particular program, I have not run it on a cluster, this is my edit to a program that does run on our cluster. I'm using Spark here as sort of a work distributor. It's, as you'll see here in a second, it's just running a user-defined function on individual rows. So I'm not using Spark ML for this at all. But the point is that I've been able to scale this up, sort of like the previous presenter, right? Using Spark to run her C++ program across a large corpus, spread out the work to get a lot done. Same thing I'm doing here. So build a Spark session. This function minus the print statements is exactly the same function we were looking at over there, over in the other notebook. And I just set up the function to turn that list of features into a string for a simple return. That's probably not useful for downstream processing, but it works for this example. Declare it to be a function so that the environment knows about it. Now what we did to make this work, we do have control over the cluster. We've installed the various Python libraries to all of the nodes of the cluster. Actually, we've got one node that we install it on, and all the other nodes copy their local config from that one. So when this job gets distributed to the executors, whatever node they're on, that executor will be able to import each of the libraries successfully. So I don't need to pass libraries and stuff on the command line. I can just Spark submit, Spark np.py, and away it goes. And the rest of this, if we assume that my documents are in some database in a table named doc, then go pick up the title and the abstract. Go get the text out of that table that's already on the cluster. Add a column where the contents of the column will be the output from the function that takes in the abstract and title as input. Get rid of the abstract and title and write it back out to some table, and now you've got all the post-processing afterwards that you'll need to do anyway. This very simple program works for getting parts of speech generated in a Spark cluster. And that's what I have. So I have lots of time for questions.
Thanks a bunch, Asoka. Let's give him a big hand. And anyone who has questions.
Yeah, very interesting. What's different in using nouns versus using something like shingles over, it's like n-grams but on words? So you would use combinations of words of, let's say, size 2.
So n-gram of size 2, a bigram. The example I use in my head, if you do a size 2 n-gram over United States of America, you find United States and states of and of America. So you'll never find the 4-word phrase, United States of America, unless you go up to a 4-gram. But if you go to a 4-gram, you're finding a whole lot of extra stuff. So that being said, I know that there are techniques for working with n-grams, for finding things that are occurring together. The way I think of it, and I don't claim to be an expert here, is you're using math to find the interesting tokens, realizing that if you need to go, if you're spending too much time looking at tokens with your business users and you're looking at n-grams, you've lost. Here you're using the part of speech to find the phrases. And so what you're finding are phrases that people use in their written terminology.
Hi, you mentioned in your future you saw having to potentially train another part of speech tagger, especially if you're working in a more technical or domain. Do you know what that future looks like for you, how you're going to approach it? Is pattern going to support that?
Well, let's see here. I don't know what that future looks like because the idea that that was my future occurred to me sometime earlier this afternoon. But my intention right now is I want to be migrating into the Spark environment wherever possible. So my first stop is going to be a Spark NLP. I know that they've got part of speech tagging. So will it do what I want to do? I don't know yet. But that's on my list of discoveries from the conference. And then I'll need to figure out how you train a part of speech tagger, because I think that means more labeling, and I spend a lot of time labeling right now. And that's going to be labeling parts of speech, and that might mean spending time with a grammar.
Hi. So, in your experience, how well does do one of these POS taggers work with a body of text that has spelling errors in them?
With what?
Spelling mistakes.
With sentiment?
No, spelling errors. Like you spelled something wrong. Let's say that in United States of America somebody spelled United wrong. Would it still pick up? Are the underlying models good enough to pick up United States of America even though it's spelled wrong?
I don't think I understand the question well. So the part-of-speech tagger itself, if this is the question, my experience has been that the parts of speech it's finding are good enough for what I'm working in right now. The idea that I would need to go train a new part-of-speech tagger hasn't arisen. I suspect it's just because we have enough analysis to do on our very large corpus that improving the analysis by improving the tokens just hasn't arisen yet. We're not fiddling over the 2 or 3% at the end. Does that?
No, but I'll take it off.
Okay, happy to chat more.
Okay, so just to coming back to one of the questions earlier. So instead of using, for example, n-grams or even skip grams, where you basically skip a few words and generate n-grams. So the main advantage here, in your opinion, is that we basically use a lot less number of features, but still can possibly get similar performance in the ML training. Is that kind of what the conclusion?
So understand that the primary driver for us was two things. One was that we generated bigrams on our corpus, and we had those generated for quite a while. And then one day, for a crazy reason, we generated trigrams. And when we came back at the end of the weekend, and it was mostly done, we deleted those from the database, and we never tried that again. Partly we were driven by a desire to reduce the number of features. We're already way more features than rows, which is typical for text. This reduced that a lot. We wanted the phrases because we believe that those will be valuable for our analysis, and this got us, relative to bigrams, a very small number of phrases where each one was very high quality. So that was part of it, fewer features. The other big driver is we want our features to look like something a human would say and something we would take note of. And this gives us that. So those are the two things that were primarily driving that. I believe that there are techniques using n-grams that we just haven't made use of where this wouldn't work, right? If you don't have bigrams, then the techniques that are sifting through the bigrams to find things that co-occur and discard the things that are just happen to, by happenstance, or next to each other, this wouldn't apply. So this is not a cure-all by any means, but if you want phrases, you don't want all the extra features from bigrams, and you'd like it to be readable, the aha for me was this was surprisingly easy to develop, and it can be surprisingly performant. And both of those were things I didn't expect.
So have you used this in a production model, and what was the performance of like a sentiment analysis or other types of predictive models? What was the performance increase from that, from switching?
So we have not used this in production. The team that I'm a part of is a pathfinding team. When we find something good, then our next step will be to hand it off to somebody who will develop it and get it into production. We're trying to work, I don't know, somewhere closer to a research space. I don't have, like I said, we're not at that stage of development where you're like, well, 80, 83, we really need that last 3 points. We're 10% is not good enough. Can we make 20?
Anyone else? One more. All right.
Thanks for your presentation. My question is, have you ever used it in the like a study case or something? You need to do binary classification using this n-gram, and there is a need to tell the body and the tail, the voice and the noise. and how you, do you have any good algorithms which can help, like a further step of the research?
Yeah. Classification is one of the uses that we are trying to make more use of. Document is in topic, out of topic. I don't have a lot of experience with it, but one thing I have done, which was one of those touchdown moments, doing document search through this very large corpus. I wasn't using classification, but I was using sort of find me more documents that are most like this set of documents. I have not compared with just standard tokens versus these tokens because these are the tokens I have and I don't want the other tokens anymore. What I have discovered was a keyword search led me in one case to about 150 documents in this very large corpus with sort of turns on find me more documents like these. And remember, it's human label. I'm the one that's inspecting. With like 2 or 3 iterations, I was able to find another 150 documents that you couldn't realistically find with keyword search that properly belonged in the topic. So the idea that the topic was twice as big than anyone thought it was, that was very interesting to me. So I have was it SVM, I believe, is the Spark ML library typically, or algorithm typically used, and it's what I'll be trying to get. I'm still learning.
All right, thank you, Asoka. If you guys have
Thank
any
you for your
further
questions.
questions, you can catch them.